So in terms of Black-Scholes model, D1 and D2 numbers are to be determined first. In terms of D1, all the formulas just remain the same. For the first 120 by 115, you need to understand the um, logarithm which will be given in the question paper. So logarithm of 1.043478 is 0.04256. So incorporating 0.02456, we are getting a value of 0.3752. D1 is equal to 0.3752 minus 0.3, which is 0.0752. Since it is restricted to two decimal numbers, we are making it as 0.37 and 0.07. And from the table of the standard normal distribution, the values of D1 and D2 are. So to get to know the normal distribution values, here is the probability table where you can, if you um, get to see this range for 0.307, you get 0.6443. And again for 0.07, it is 0.527, incorporating it in the sum. So n normal distribution, this is normal distribution probability value of 0.37 and 0.07. So you get 0.6443. So it is here, and here it is 0.5279. So the values are basically taken from the normal distribution table. So that is the base. The next point we have is how do we, so what this basically implies is if the price of the underlying share ABC rises by rupee 1, the stock price increases by 1, then the price of call option will rise approximately 65 paise in terms of call option. The while the price of the put option, basically the right to sell that option, will fall out by 35 paise. So this is the understanding. Then coming to the point of put option value using the put call parity theorem. So we have two formulae. One formulae talks about how you need to calculate your call option. Another one, how you need to calculate the put option. So in terms of calculation of call option, the formula goes like this. I could not exactly locate it in the PPT, so I have no, picked it up from the site. So the formula goes here. So theoretical market value Black-Scholes formula is, first is C stands for call option, S stands for current stock price, capital N basically stands for standard normal cumulative distribution function. D1 is the one which we have no, determined in terms of volatility, D1 and D2, and those numbers. D1, D2 we have determined, and the normal distribution table of D1, D2 are specified here. So stock price into ND1 minus X is basically the strike price. Strike price is otherwise called as exercise price, also called as option premium, into e to the power of minus R. R is risk-free interest rate, which is annualized. Annualized means for 1 year. Into T is time to expiration, which is expressed in years, into ND2. So again, D2 is the value which we have determined. ND2 is the normal distribution value of the D2 part. So that with this formula, we need to do few calculations for this sum. So it comes like this. The current problem, so this is the problem we have. Just incorporate the values and find out the answer. This is all more of a formula substitution. So the current price here is 120. Yeah. So next we have capital N. So capital N basically talks about standard normal cumulative distribution function of D1, which we have already determined. So which we normally call it as capital N of D1. So capital N of D1, capital N of D2. So 0.6443, 0.5279. So N D1, D2 we have here determined. Now E to the power of minus RT. So R is nothing but 0.10. So capital T is basically the time to expiration. So here it is 3 months. So rest are all fine. When they say F, it is the current stock price. X is nothing but exercise price. What is exercise price? Exercise price is the price which is basically entered, which price is agreed between the seller and the buyer, stating that irrespective of any change in the prices in future, the agreement says both the parties should stick to the excise price. So that is the agreement. So excise price is the price which is already in advance agreed between the two parties. So S is the current stock price. So all these data are given. So as far as the sum is concerned, the current stock price is 120, excise price is 115. So all these details are there. We need to just substitute it and find out the answer. This is all forming part of the 10 marks problem. So taking those factors into consideration, so let us substitute it. So it is like this. So 120 into 0.6443 minus excise price is 115 into e to the power of minus 10 into 0.25. 0.25 is nothing but 3 by 12. So this 3 divided by 12, you will get 0.25. So that into e to, see this e to the power of minus 0.10 into 0.25 comes to this value of 0.025. So since I don't have no power, I'm just putting it like this. CAD it minus 0.25, 0.025. Hope you are able to understand. And then into again multiplied. What is n? D2 is again we have the figures here 0.5279. So e to the power of minus RT is the values will be given in the question paper. So on substituting that, you will get a value of 8.11. This 2 you need to multiply minus 115 into that e to the power of minus e to the power of minus 0.10 into 0.25. So let me get to the values. Value of minus 0.10 into 0.25, 0.10 into 0.25, so 0.10 into 0.25, 0.025, so 0.025, so so on substituting these values, so it comes to 1.025315. We can restrict it to two digits, so 1.02. Hope you are able to understand. 1.02. So in terms of multiplication, 120 into 0.6443, so you get a value 120 into 0.6443, you get a value 77.316. Then 115 into 1.02 into 0.5279, you get a value 61.922, 61.92. So on subtracting both these two values, you get a number of 15.40. So 120 into 0.6443, 120 into 0.6443, then 115 into 0.5279, 115 into 0.5279, 60.7085. In terms of e to the power of 0.10 into 0.25. So just we have to determine it. These normally answers will be given in the examination. So let's put it here. So let me explain it again. So 120 is your um, current stock price, and this is your ND1 value, minus 115 is your exercise price, which is otherwise called as strike price, into e to the power of 0.10 into 0.25. The values for this will be given in the examination, into 0.5279. So taking that value here, so we get 120 into 0.6443. So 120 into 0.6443 is comes to 77.316, minus 115, multiplying it by 0.5279 into, so e to the power of minus 10 into 0.25. So already we have that number 0.9753. This will be given in your examination. So if we multiply, so it is 0.9753. So we are getting 59.20. So 77.316 minus 59.209, you can round it off to 21. Yeah. So 77.31, probably 32 minus 59.21, which comes to 18.11. These are calculations where you have to be very, very careful in multiplication, picking up the E number correctly from the question paper. That is all very important. Then coming to the point of put option value. See, as far as put option value is concerned, it is actually, in short, it is called as put call parity theorem. Normally, put option value is calculated by predominant of the trading platforms with the help of this formula, where you can get a approximately a genuine number. So put option value is equal to, for put option value, you need to have call option value. So call option value plus E stands for exercise price. E to the power of minus RT is a mathematical constant, where it is a continuously compounded risk-free rate of interest in the time remaining before the expiration rate. Normally, it is expressed as a fraction of the year. And so S0 is your current price. S0 is your current price. It is normally expressed as C or S0. So you have to be very careful with the um, formula or the alphabets which you are trying to express it. In terms of C, it's a call option value. So substituting this formula, we'll be able to obtain the put option value using the Black-Scholes model, and it can be called as a put option value calculation or put call parity theorem. Yeah. So in terms of substituting these numbers, we already have the call option value plus E basically stands for exercise price into again E to the power of minus RT. Already we have that number in hand. It is basically 0.9753. So on substituting it, we'll be getting a value of 10.27. Let us do the calculations. So, so call option value with a number which we have already found it out, that is the base for this, plus 115 into, so E basically 0.9753 minus 120. So so adding these two, 18.11 plus this minus 120. So you are landing up in a value of 10.2695, which is normally rounded out to 10.27. So this is the value of calculation of put option value. So first we found out what is D1, then D2, then we found out the normal distribution values of D1, then we found out the normal distribution values of D2, then we are arriving at call option value, then we are arriving at the put option value. You need to substitute the numbers of e to the power of minus 0.10 into 0.25 appropriately. Pick it up from the question paper correctly, and wherever normal distribution tables are given, probably try to align the numbers of D1 and D2 correctly and calculate the call option value and put option value. This is, you will be getting 5 marks. So coming to the point of, this is one part of the question we are trying to solve here. So this is called as valuation of put option and call option. Yeah. So any doubts? So So we are trying to prioritize the Black-Scholes model, the detailed question, which is 20 marks question. Hope you are clear with this point. So call option we have completed, put option we have completed. Now we are getting into the next understanding of how to derive at first is delta, this point. So there are two parts of this question. One is they've asked call option, put option. Other one is they've asked about the various components of Greeks. So first comes the part of delta. So delta is basically, which I already told yesterday, uh, delta is a significant byproduct of Black-Scholes model, extensively used where options form part of their portfolio management. So deltas are measurement of volatility of option premium. It's a measure of probability and a hedge ratio. As far as delta is concerned, all any positive delta which will range between 0 and 1, negative delta will range between 1 and 0. And as far as gamma is concerned, gamma is basically proportional. Whenever there's a change happening in delta, that change is quantified by gamma. Simple. As far as Black-Scholes model, Greek's components are concerned, delta is connected with gamma, gamma is connected with um, uh, theta, theta is connected with rho, rho is connected with vega. So this is a chain. This has to be studied as a full part and not in breakups. So just trying to um, do a recap of delta, what we studied yesterday. So when we say delta equal to 0.7, what it means is for 1 unit change in stock price, the option would have been 0.7 points. Similarly, if a delta is a negative number, minus 0.8, for a put option, then put option premium will decline by 80 paise if the underlying stock price rises by 1 rupee. So it basically, if the stock price rises by 1 rupee, if the delta says one number in positive and the beta delta says another number in negative, the interpretation is basically like this. So uh, the option would move 0.07 points up. Yeah. The put option will move in a downwards manner by 80 paise. So that is the understanding of delta as a measure of volatility. So in so formulas are very important here. For a call option, the delta is ND1. For a put option, delta is ND1 minus 1. So what is ND1? Normal distribution probability table of D1 numbers, which we find in the initial phase. So next coming to the part of gamma. Gamma, as far as gamma is concerned, one formula, gamma of put, gamma of call are almost same and is either be positive or negative. Gamma is normally calculated as in this manner. Z1 divided by Z0 sigma into root T. So it is actually a proportional change in delta. So gamma is a continuity of your delta part of it. So it is like this. Theta will be a theta is stands for T. So theta is basically whenever there is a change in the time, a lapse of time, and that is having an impact in your option. That is that becomes that will be quantified by theta. Okay. So delta, gamma, theta are three components of Greek which are very important, followed by rho and vega. Rho and vega, it assumes an importance, but it assumes a minimum importance compared to gamma, theta, and rho. Delta, gamma, and theta. So coming to theta, it is more like change in the time decay of the option value. So the theta basically talks about the time decay of the option value. It is always negative. Theta is always negative. It is quantified always negative. The formula also starts with negative. And for call option, you have one formula, and for put option, you have one formula. So it is always whenever you are asked to take a scientific calculator, the normal distributions or the log values can be easily determined there. So the formula goes like this: minus S0 into ZD1 into standard deviation divided by 2 root T minus E into e to the power of minus RT. And then you have R is nothing but rate of interest, and D2. So for call option, it is always minus, minus, and then D2 will be plus. For a put option, it is minus plus, your bracket will be minus for your D2. Rho, rho is whenever there is a change in the interest rate. how the options gets affected. So change in interest rate impacting the option value is quantified by rho. So rho is basically both rho for a call option, it's a positive. For a put option, it is negative. And it is like E into T. Capital E is exercise price, T is the time. Uh, so into e to the power of minus RT n dt. Here rho is for put option is minus E t e to the power of minus RT into n minus d d2. So the base values which we found initially for the call or the put option, it, as is it has been no, applied in all the formulae. So that is rho. Then comes to the part of Vega. Vega is known as kappa or lambda. Vega is known as kappa or lambda. Vega is basically whenever you have a volatility of the underlying stock. When I say volatility, it is the fluctuations. So whenever there's a fluctuations, which is basically impacting your option value, so that is called as that is being quantified by Vega. Vega is always positive and identical for call and put options. Yeah. So for the black shoes model, Vega can be obtained as Vega is equal to S0. So what is S0? What is S0? S0 is basically the current market price of the share. Current stock price of the share is called as S0. So here, so for Vega, it is S0 into root T into ZD1. So ZD1 formula applies same for all delta, gamma, theta, rho and Vega. So e to the power of minus D1 square divided by 2 divided by root of 2 pi. Pi is always, what is the pi value? What is pi value? 3.14159. So it can be rounded off to 3.14 or 22 by 7. So it is the pi value. So symbols are very important here. Pi, standard deviation, theta, gamma, delta, vega, rho, all are very important. Okay. So we have done a recap of the formula. So let us go to the problems one by one. So coming to the part of calculation of gamma. So let's take it like this. We have already aware of all the parameters whatever is required to be applied in a formula. So we have this formula tab where I have consolidated formula for all the areas for no, theta, for delta, gamma, theta, vega and rho. Okay, so in short, delta is what happens if the stock price is increased, is being quantified by delta. Theta is what happens if I reduce only the time. Whenever there is a time decay, what happens? So what happens if uncertainty happens? That is quantified by Vega. What if the interest rate changes? That is rho. What happened to delta when the stock price changes further? So delta and gamma, they are completely interdependent, and gamma uh, is a tool which determines the change of delta. Okay. So instead of recalculating the entire formula every time, the Greeks tells how sensitive the option premium is to each factor. Option premium is nothing but the strike price or the excise premium. Yeah. So let us go to the problem. So for a call option, delta is ND1. For a put option, delta is ND1 minus 1. So applying that here in the problem. So let's go to the problem. So first part we have completed. So delta is very simple. We have already found out delta. So delta is 0.6443. And for a call option, for a put option, delta is 0.3557. Okay. So, so the understanding goes like this. If the price of the underlying share ABC increases, then by 1 rupee, the price of the call option will rise approximately 64 paise, where the price of the put option will fall by 35 paise. So this is the understanding. So instead of just going through the formula, try to understand the basic concepts, not at a very high level. Only when you're going to get into a practical forum, you'll be able to appreciate the black schools model. But for examination purposes, let us crack it like this. Next, coming to gamma. Gamma is more of application of formulae. So let's crack out gamma part. So the formula for gamma is ZD1 divided by S0 into standard deviation into root T. So what is ZD1? E to the power of minus D1 square divided by 2. So to get to those formulas, so let us put it like this: E to the power of D1, which we are already aware, 0.3725 D1 is. So we have D1 0.37. So this is the base. D1 and D2 we have. So applying it here, D1 we have standard deviation 0.6, T is 0.25. So now while applying e to the power of minus 37, so how do we get 0.37? You need to pick it up from the base information, which we have found out in the very first step. So 0.37, the whole square divided by 2. So that basically we will get it as 0.37. So when we square it, it becomes plus uh, that divided by 2. So 0.68486845. So e to the power of minus 0.6848, e to the power of e to the power of minus 0.06845, 0.06845. So we are getting a value of 1.07. Point 0.06845, 1.07. So here when we are going to that divided by root of 2 pi. So when we say root of 2 pi, it is, what is pi? Pi is 22 bar 7. So 2 into 22 divided by 7. That square root we are getting 2.50. Yeah. So 2.50. So this divided by this, we are getting 0.428. Uh, Let me put it again. The power of minus 1 minute. So 0.933, 0.933, 0.37. So this is how you normally calculate it. You need not have to worry about e-values. E-values will be given in your examination. E-values, normal distribution, probability table values, all will be given. But just to make you understand how we arrived at 0.685, it is like this: 0. E to the power of minus 0.37, the whole square divided by 2, you have to perform it. From there, you have to find the e value divided by 2 pi. Pi is 22 divided by 7 or 3.14. So 2 into 3.14 root you have to take. You will get you will get to a value of 2.5. Yeah. Anybody having doubts? Okay. So this divided by, there is 0.933 divided by 2.5. If you do this, you will come up with a number of 0.3732. So almost it's nearing up. Then you apply the gamma formula. Yeah. So what is your gamma formula? Is a D1. Is a D1 is the value which you have found it out. So gamma is equal to, see, this entire part is about is a D1. Okay. This is a D1. So gamma is equal to 0.3725, that divided by, what is S0? Is your current stock price. 120 into, what is your standard deviation? 0.6 into, what is your root t? How did you get 0.25? 3 by 12 is equal to 0.2. Out of 12 months, the expiration date is only 3 months. So 3 by 12 is 0.25. So 0.25, if you do square root, you get 0.5. So that's where we are landing up in a figure of 120 into zero point 0.6 into zero point 0.5. So let us do the calculation. 120 into zero point 0.6 into zero point 0.5. So 0.3725. So this divided by this. So 0.010347222 is your answer. So this is your part of gamma. So do it. So this part is ZD1. Yeah. Calculations are very important. Do it very slowly. So we have completed gamma. So when I say 0.0103 gamma, so what it implies? What it implies? When I say gamma 0.013, it implies that if my stock price is going to increase by 1 rupee, it will increase the call delta. Okay. The gamma is a continuation of how the delta travels, right? So how the call date will increase the call delta by 0.0103. So with the current price of 120, the call delta is at present 0.64443, right? But if the stock price was to rise from 120 rupees to 121, another rise of 1 rupee, this would, what happens? The delta would increase to 0.6546. That is the indication. Similarly, this is for call option I told you. Similar for put option, what is understanding? It is minus 0.3557. This would change to minus 0.3557 plus 1 of, when it happens, when my change in the stock price from 120 to 121 rupees, if it increases, then my put option, the delta would change to minus 0.3557 plus of 1 of 0.0103, that is minus 0.3454. Remember always, for gamma, your delta should always be taken into consideration. Only then your interpretation will be correct. So this is all about gamma. Yeah. So next we have completed delta, gamma. Now we are going to go to theta. So theta, what is the formula? For a call option, it is always negative. For a put option also, it is always negative. Yeah. Theta starts with T. Time starts with time. So any time decay of the option value that is having a predominant impact in the value of the option will be quantified by theta. So theta formulas we have already given. Yeah. You just have to incorporate the values here. So see, but it is not only the calculation of formula, it is always important that you try to interpret the numbers, what it is basically conveying, what is the storyline behind it, how the numbers are being connected to the sum. How should we understand it from a layman language? So that is all very important. From examination point of view, it is good that you arrive at the numbers, you solve it, you get to a number. But what do you understand from it? End of the day. So that is also very important. So try to interpret the numbers and understand it in connection with the problem. So delta we studied. Delta is very straightforward. Gamma we have few workings. Theta has got some detailed workings because you need to do it. See, for gamma, it is only one formula, right? Irrespective whether it's a call option or a put option, it's either positive or negative. But for theta, it is not like that. You will have to be very careful. For a call option, it's similar same type of formula, but wherein your signs differ. For a put option, it's an opposite thing. So you need to be very careful. Let me enlarge it. So So let's take it like this. So just substitution of numbers. So S0 120, SD 0.6, T is 0.25, E is 115, R is 0. D1 we know, D2 we know. Yeah. So again, when I say D1, you have to go back to your delta. So you have all the numbers there. So D1 is a calculation which we did 0.37, 0.07. Yeah. So from there you try to grab the numbers. Substitute the formula. What is the formula for a call option? Theta is equal to minus S0 is 120 into what is ZD1? 0.37. What is standard deviation? 0.6 divided by 2 into root T. What is root T? 0.25. First, always take the square root of 0.25. So, square root of 0.25 is zero point 0.5. So, zero point 0.5 into zero point 0.2 will be your denominator, which is zero point 0.1. Yeah. So, so ZD1, we got it in the previous problem itself, 0.3725. Remember this one. So, this will be your subsequent, even for theta, you can apply it. So, it is 120 into 0.3725 into zero point 0.6 divided by 2 into root 25. This is one calculation. So this entire thing is one calculation. 115, okay, into 0.10 into 0.25. What is 0.10 into 0.25? Again, we need to take the E value 0.10 into 0.25. So which is 0.025. So e to the power of minus 0.025, let's put it 0.025. So we are getting a value of 0.9975. So we will work it out here. First we will work it out this part and this part, okay, so that there won't be any confusions. Whenever there is a minus or whenever there is a plus, you will have to apply those two operations as per Bodmas rule. What is Bodmas rule? Bracket of division, multiplication, addition, subtraction. So your addition and subtraction should come last. So first you will have to crack out this part, then this part. Yeah, let's start. So theta is equal to, so what is S0? 120 into Z1, which we have already found out in the previous problem. Yeah, 0.3725 into what is standard deviation? 0.6. Standard deviation is nothing but the volatility, 0.6. See, these attributes will be given in your problem. You just have to write the formula correctly, substitute it properly, pick up the E numbers properly from the question paper. That's very important. Or if not given, use your scientific calculator to work it out. So then divided by 2 into square root of, I don't have the no square root symbol here. So I'm typing it as square root of 0.25. So this is 120 into 0.3725. Yeah. Any doubts? Into zero point 0.6. So this is your numerator. So denominator, what you have to do? 2 into What is root 2? What is the square root of 0.25? 0.5. So 26.82 is the value of your first part. Okay, now we are going to into the second part of it. This is the first part. What is the second part? You will have to substitute e into e to the power of minus rt. What is e? E is 115 into e to the power of minus rt. What is e to the power of minus rt? E to the power of minus caret sign. What is r here? Rate of interest 0.10 into what is t here? 0.25, correct? Okay. Into e to the power of minus rt into, we will have to substitute rate of interest, right? So 0.10 into ND2. What is ND2? The second part of it which we found out, right? That is 0.5279. NDT is this part. 0.3557. Okay. 0.5279. 0.5279. The values are here. You have to be very careful in copying the values. 0.5279. So here are the values. I'm just incorporating it here. So what is 0. 0.10 into 0.25? What is 0.10 into 0.25? 0.10 into 0.25. 0.10 into 0.10 into 0.25. So 0.025. So e to the power of minus 0.025. So let us put it e to the power of 0.0. 0.9753. 0.9753. Okay. 0.9753. So this is the entire value for the e to the power of. So that 115 into 0.9753 into 0.10, yeah, into ND2. What is ND2? 5279. 0.5279. So what is the value you are getting here? Is equal to 5.92. You're able to understand. See, these are values you have to be very careful in multiplying and also taking the e to the power of minus values. So sometimes it is um, by mistake we might neglect the minus sign. You have to be very careful in including the minus sign and then do the calculation in a scientific calculator. So this is how we are getting. So first part is 120 into 0.3725 into uh, zero point 0.6 divided by 2 root of 0.25. That calculation is over. You're getting 26.82. So this is the first part of it. Okay. The second part goes like this, where you need to be very careful in picking up the figures for e to the power of minus value from your scientific calculator or from the question paper. Be very, very careful. So the theta for the call option, it lands up in a figure of 26.82 minus 5.92. So theta call is basically 26.82 minus 5.92. Yeah, so when we say 26.82, so the final answer is 20.9. Sorry. This is also minus, right? Forgot. So minus it is. So it is minus 32.74. So always remember, theta answer will always be in negative value and it won't be in positive. Theta values will always be in negative and not be in positive. So please remember it. So do it now. So this is the first part. This is the second part. Theta, combining both the parts, we are getting a value of minus 32.27. Rho and vega are pretty straightforward. So, so there are formula, but you do not have to get so much in depth with these numbers. Will be straightforward, but for as far as delta, gamma, and theta, you have to be very careful. So theta call is over, right? What is the difference between theta call and theta put? Anyone? What is the difference between theta call and theta put? Right. So theta call and theta put, the only difference is the signs you have to be very careful. And the one part, the last part, where here we say 0.5279, here it will be 0.424721. So what you exactly do? N of minus G2 we are doing it. How do you do it? How do we come to 0.4721? Just think. N of minus G2. How do we get it? So when ND2 is, what is the number we are getting? Mm. So ND2 is 0.5279. What is N of minus D2? Mm. So to determine N of minus D2, let me explain the procedures. here theta is equal to the same thing, minus 120 into 0.725 into 0.6 divided by 2 root 0. The first part remains as is. Okay. The 26.82 remains as is. Here minus, here it is plus. 115 into, what is the value we got it for e to the power of minus, this one is 0.9753. That into 0.10 into 0.4721. Any idea? Mhm. Think n of minus d2 will be given in your problem itself. Will be given in your question paper itself. You need not have to worry about it. Okay. So let's take it like this. So when I say n d2, yeah, when I say n d2 is, what is n d2? 0.5279, right? When I say n d2, when this one, n of, so what we exactly require is, what do we require exactly? We require n of minus d2, right? So how do we do it? 1 minus, yeah, 0.5279. So when you subtract, we get the remaining portion, which is 0.47. That is how we derive for 0.471. So this 26.82 remains the same. Yeah, there is no change. See, this is one part of call option. For the difference between your theta call and theta put, the differences are, it starts with minus followed by plus, then we will have to apply nd2, which is 0.4721. Yeah. So on substituting 0.427, you get put. So you come to a number minus 21.42, right? So what it implies when I say theta minus 32, what it suggests? If time to expiration were a year longer, yeah, then the value of the call shall be up by about rupees 32.74. The time decay was about 0.09 per day, obtained at rupees 32.74 divided by 365. Why are we doing 365? So for 365 days, it is 32.74. Then for one day, how much it is? 32.74 divided by 365. So 0 point, somewhere it lands up at 0.089, which is 0.9 per day will be my time decay. How can I no, tell it in a much simpler sentence? It means that a day, whatever is near to maturity, would cause a fall of 9 paise in the price of the call option. Okay, what it happens, a day nearer to maturity would cause a fall of 9 paise in the price of call option. You see, it is like this. See, ticket you have booked 1 month ahead for a travel to some Tirunelveli. Yeah, if you cancel it, I think within a period of 1 week, you will get some amount of, refund, right? Suppose you cancel it only just not even you have 24 hours, then you cannot have a cancellation amount or refund amount. So similar to that, whenever it is nearing to the maturity, the fall will be 9 paise in the price of the call option. So similarly for the put option, it would experience a fall of about 21.52 divided by 365, which is 6 paise. For 365 days, it is 21.52. So for one day, how much? Therefore, each passing day, towards maturity. So this is how you calculate your theta. Hope you are able to understand. So let's park it Vega. Yeah. Vega we will park it. Vega is a straightforward thing. Let's take it as an exam homework and complete it. Probably we will catch up it tomorrow to complete row and Vega. So that once we complete row and Vega, we are completing the entire 10 marks sum of the Black Schools model. Yeah. Okay, fine. Any doubts? So let me forward it to you. It will be easy for you. So we have completed delta, gamma, theta, that portions today. So very important. You need to practice it. Only if you practice, you will be able to understand better. Just copying the answers will not fetch any results. Please be very careful on that. So any doubts, please do let me know. But you have to put it as a homework once and you have to practice it 2 times, sir. So the last two parts are very simple and you have also to by heart the formulae. If you have any, if you foresee any challenges in by hearting, please do let me know. I will try to give you a no trick or something clue where you can crack it out. Please do not leave this chapter. So you have a no uh, compulsory question in Black School's model. So it is very important that you take lot of time and practice it. That's very important. So it's all about today's class. So I'll upload the recording and we'll catch up tomorrow. Yeah. Okay. Bye bye.